So when you do these crosses, you're going to fill out the boxes like you would with a normal cross. And so here in this first box, you would have X big H, X little h. Here, X little h, X little h. Here, X big H, Y. And in the last box, X little h, Y. So you can then use these results to kind of analyze them. And remember that you need to be looking for, one, if it's male or female, and two, whether it's affected by the disorder, whether it's a carrier, or whether it is unaffected by the disorder. So if we look here at our first question, what's the chance of having a daughter with cystic fibrosis? Remember, it's a 50-50 chance of whether you have a daughter or a son. So these top two here are the daughters, and we're looking for whether they would have cystic fibrosis. So since it's a female, they would have to have the two recessive alleles to actually be affected by the disorder. So you can see here, this one right here is affected by the disorder. And you're just looking at the females, you're not looking at all the children. So one of the two females would be affected by the disorder, so that would mean that there's a 50% chance that they would have a child with cystic fibrosis. So that would be your answer to the first one. Now, the second question is, what is the chance of having a son with cystic fibrosis? So you look at the sons, which are XY. One of the two would be affected, because remember, they only have two options. They can either be unaffected or they can be affected. So once again, one of two sons could have it, so that is a 50% chance, once again. So there's a lot of different things that you can do with this. You can look at this and you can predict what the parents' phenotypes would be by having the children's genotypes. So if I said something like, a boy has cystic fibrosis, and we don't know what the genotype of either parent is. I mean, you wouldn't really know whether the father had it or not, because the father always gives the Y, but you would automatically know that the mother had to be a carrier, because she would have passed that recessive trait on to her son. And at least there was the possibility if you knew that. So you would automatically, know what her genotype, well, she could have had the disorder, I guess, too. So you would have known it would have been one of two possibilities. But you can tell a lot of things from analyzing these Punnett squares, and you should be able to go back and forth between whether you have the parents' genotypes and you're trying to figure out what the offspring would be, or vice versa. You have the offspring and you're trying to figure out what the parents' genotype is. So hopefully that helps a little bit more explain these sex-linked traits and how to analyze the results.